Okay, today we are going to be talking about slope in class, and some people might have heard it as slope or they might have heard it as rate of change. So we're going to be using both of those vocabulary words as we start our lesson. Your teachers from last year have probably told you the different types of slopes, but today we're going to be focusing on finding slope from a graph and counting slope, as well as finding slope from a table and 2 points. So the easiest way that I can help you guys understand this is to think about a map and to think about kind of some streets. And so right now I have two houses. I have one house here and one house here. And it's kind of like you're going to your friend's house. Now, if my friend's house is here and I'm over here or whatever, it doesn't vice versa, I can't just walk a straight line like that, okay? That's not going to work. Part of that is because, well, you have fences, you have streets, you have cars. So the same thing's going to be true when we find our slope between our 2 points that we have here today. Anytime you're finding the steepness or the rate of change or the slope of a line, you're not going to be able to count your slope like this, because we're not going to be able to go through our lines or through our fences or through our neighbor's yard, okay, right? So our goal is to get from this house to this house with the fewest amount of turns possible. So if I'm over here on my street, I'm going to have to go down my street like this, boop, and then I'm going to have to go over. So I'm not going this direction. I'm not going like this, kind of like a staircase and so forth. You can even go around. There's lots of different ways you can do this. However, I want to do it in the fewest turns possible. So in this case, I'm just going up this Louisville Avenue, and then I'm going over on 39th Street. So let's actually count the number of streets that we've got. So we've got 1 street, 2, 3, 4, 5, 6, 7. So I went 7 blocks, whether walking, running, whatever you want. Then coming off of Louisville Street or Louisville Avenue, I go 1, 2. So then I went 2 blocks this way. So 7 blocks up and then 2 blocks this way. Okay. So that's, if we were trying to find that steepness of our line, trying to find the slope of this line, then look at what we kind of just created with that. Again, we can't count these right here because those are going through people's yards. But we can go down the street here, and then I can go over this direction. Now, if you look, we've created what you guys might remember as a right triangle. So when we're finding our rate of change and finding our slope of our line, we're going to be looking for this right triangle. We're going to do this by going up and then over. So starting with our lowest point down here, going up to this guy here, making that right triangle, and then over. So fewest turns possible, and always start with that lower point. And this is how we're going to be able to find our slope for today, or how we're going to find our rate of change. You're going to be taking those right triangles. So let's go ahead and let's take it down here to our notes, and let's talk a little bit. Slope represents the rate of change. Slope should be written as a fraction. So we're going to write the word fraction in simplest form. Now, that may be kind of weird just because you haven't seen it in a while, but I promise you it's really not that bad. We have, let's say I have a fraction with 8 over 12. Well, that 8 and that 12, they both have factors that can be divisible that are in common. So, for example, 8 can be divided by 4, and 12 can also be divided by 4. So if I divide 8 by 4, I end up with 2. And if I divide 12 by 4, I end up with 3. Now, there's not another number that 8 and 12 have in common that they can be divided by. So we would say that this is in simplest form. Okay, we take that fraction and we simplify. Now, you can also do this in your Desmos calculator. So I'll pull this guy over here. It's a little big, sorry. And let's take that 8 and divide it by 12. Now, it's going to give you a fraction, right? Or it's going to give you decimal, but you can always change that to a fraction by clicking that little dot right there. And see, 8 divided by 12 can also be written as 2/3. So we're going to be doing that as well with our slope today and using the idea of that map as we find the slope. Okay. Now, slope is the vertical change over the horizontal change. It's represented by the letter M. So we have this way to remember it. We have our M is equal to rise over run. The other thing you might see it written as this, change in Y over the change in X. And again, that delta right there just means change. So the change in Y over the change in X. So let's talk about that for a second. I'm going to go back up here to our map, okay, just to kind of give you some context of this. So let's pretend for just a second that we have a coordinate grid here, and I'm going to make this a little thicker, sorry. I'm going to go like this, and then I'm going to go like this. Okay, so we have our x-axis down here on the bottom, and then we have our y-axis here on the top. Okay, so these are our negative values, these are our positive values. And then we have these points that we got here. These are going to be our little houses, right? So let's pretend that we were on our x and our y-axis. If I were to go up, just like what I did on my little housing grid, boom, 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 just like this, think about what axis I'm going on. If I'm going up, then I'm going to be going vertically. Okay, so I'm going to be going along the y-axis. So starting way down here, let's say this part here is 0, and then we go up 7, 1, 2, 3, 4, 5, 6, 7. Then on my y-axis, I'm going up here by 7. So I moved 7 blocks up. So the change in my y-axis is I went from 0 all the way up here to 7. Then it's talking about the change in x. So we're going to come over here and we're going to look at this change in x. So I started on my x. Let's say this is 1, 2, 3. This is -3 on my x. Then I'm going over to my house. 1, 2. So I went 2 blocks to the right. So let's call that like -1. And that's going to be my change in my x. So when we find slope, again, the change in y over the change in x, then what we're doing is we're finding this number right here, and we're finding this number right here, and then we're going to put them in as a fraction. So we're going to put our 7 over 2. So our slope of this line is 7 divided by 2. Okay. So all slope is the change in y over the change in x, finding the displacement between our house down at the bottom right here and our house up at the top. Now we have to use our slope in this guy because we cannot count like this. Okay, you cannot go through your streets and your backyards and all that good stuff. So that is what rate of change is. And our rate of change is going to help us find out how steep this line is, because lines have a steepness. Some go really steep like this, like a mountaintop, and then some are a lot less steep, right? So lots of different ways you're going to be seeing slope and rate of change today, but this is just an easy example. So let's take it back over here. Again, M is going to be your letter that's going to represent slope, and you'll get more practice with that as we go. But I just want you to remember that slope is always our rise divided by our run. So the change in y over the change in x. Another way you can think about this is, let's say you're in a building. I'll make this a little skinnier. Let's say you're in a building, right? It's like a high-rise building, or let's say it has 5 floors, okay? You walk in your building. You're not going to magically be on the top floor, right? You're going to have to go in. You're going to have to take the elevator all the way up to the top, and then you can get out and you can go on the 5th floor. The same thing's going to be true here. We're going to have to rise, okay? Rise on our y-axis, just like the elevator, and then we can run on our x-axis before we can find our slope. So always remember, it's rise over run. And guys, I'm not even kidding. Like people, they'll get the numbers right. They just end up accidentally switching them. Don't switch them, okay? You gotta make sure you remember, you rise before you run. Same thing if you're like sitting in a chair at school or not at school or sitting at your table, right? You have to stand up out of your chair before you can walk to the kitchen or you can walk to the door or whatever. Okay, so always rise over run. Now, I'm going to give you guys a couple of examples as we go through. This will just kind of help solidify your thinking, and we'll do actually a couple of examples on this notes page, but you'll be able to go back and look at the notes as well. So let's take a look at this very first line. So very similar to our grid that we got going on with the map. Okay, we're going to start with our lowest point right here, and then we're going to be going to this point. Common mistake, people do this. Okay, you cannot do that. You cannot go through somebody's yard. So trying to go to that other house with the fewest turns possible, we're going to rise first, and then we're going to run second. So let's go ahead and let's count that. We got 1, 2, 3. So we rose 3, and then we're going to run 2, 1, 2. So we ran 2. That's it. Now notice how we created this right triangle right here, making that 90-degree angle. And also, this is what we didn't do. Look at what I didn't do. Okay, so when you do this, just like the streets, just like if you were driving, you can't go in the middle of your streets. You have to make sure that as you make these little bubbles, they hit those little four square right here. Okay, it has to hit in those 4 spaces. You can't do halvesies because you don't know exactly if that's a half. Okay, so we've got 3 bumps up, and then we have 2 bumps this way. So here's how I would write my slope. M is always the letter that we use for slope. We take our rise, which is our change in the y value, so the vertical, which is this guy right here, divided by the change in x, which is the horizontal right here. So that's going to be our 2. The last step of this is you're going to make sure that 3 divided by 2 cannot be simplified anymore. So the way that we do that is we bring out our calculator again. I'm going to go ahead and clear that, and I'm going to type in 3 divided by 2, click enter. Now, if you notice, it still gives us that decimal. However, if you hit that little button right there, it'll check it for you and make sure that you did it correct. Okay. Oh, sorry, I didn't want to do that. Okay, so our 3/2, that's the slope of our line, the rate of change of our line, and that is in simplest form, so we know it is correct. Okay, let's take a look down at this one. Very similar. Now, if you notice, which one of these would be steeper? Would it be this line right here? Or would it be this line right here? So think about that as we do our work today. Now, I've already given you guys what we call pretty points or perfect points. So in this case, this one right here is a perfect point. Okay, now think about that for a second. Why is it called a perfect point? Okay, I'll give you an imperfect point. Okay, that's not a perfect point. This is not a perfect point. Now, this right here would be considered a perfect point. However, that perfect point is not on my line, so we're not going to use that one. So all of our perfect points, they have to be on our line, okay? And they have to be at this intersection between my 4 squares. So in this case, I've got 2 perfect points right here and right here. Now, if you notice that our line, there is another perfect point, and that other perfect point is going to be right here. However, we're not going to use it because I'm not asking you to add perfect points to it. I just wanted to show you what that looked like. So just like our grid, okay, just like our map, we're going to be going from this bottom house here to this top house here. Okay, we want to do it in the fewest turns possible, and we always start with our rise. So we're going to rise first. Okay, and then we're going to run. Now, some people like to put their right triangle first, okay, and some people don't. So I like to put my right triangle first so that I know that I'm making the right bumps before I do them. But if you didn't do that, then it would look something like this. We go down street 1, street 2, so I've covered 2 blocks, and then I go down 1, 2, 3, 4 blocks. Now, again, the reason why I like to do that right triangle is because sometimes people accidentally make a mistake and they go a little bit further because the paper is really small or something like that. So I think it's a good idea to go ahead and draw that right triangle first. And over here, so you see that. Still got 2 bumps this way, still got 4 bumps this way. Now, as we're writing our slope, okay, we're going to take the amount that we rose, which we rose 2. Okay, so we got our plus 2. And then we went this direction to the right. 1, 2, 3, 4. Okay, so we got plus 4. Now, we're not finished with this problem, and the reason why is because 2 divided by 4 can be simplified. So always make sure you check your, always make sure you check your fraction. I'm going to go ahead and do it here. Okay, we've got 2 divided by 4. We click enter, boom shakalaka, there it is. And again, we're going to make sure that we put it into the simplest fraction, which is 1/2. So now we can come back over here, and this guy is going to be 1/2. So there is our slope. Now, really quick, let's talk about direction on this one, because that's going to be another important part when you're finding your slope or your rate of change is your direction. Now, if you noticed, this first one, we went up, okay? Whenever you go up, it's always going to be adding. So thinking about it on a number line, if you're over here, if you're down at, let's say, 1, 2, 3, 4, if you're down here at -4 and you go up to 1, 2, okay, that's going to be here at -2. So we're actually adding, right? So anytime you go up, you're going to add. And then, very similar to a number line that was horizontal, let's say we're here at -4, and we go 1, 2, 3, 4, right, because we got 4 bumps, then we're going to be here at 0 because we are adding 4 to it. So every time you go up, and anytime you go to the right, you're going to have this plus sign. You're going to keep it positive. It's going to stay positive. And that's going to be something that I want you to add to your slopes as you do this. I promise you it'll help with your direction. All right, let's take a look at one that is kind of in contrast to that. So still we got our straight line. Now, do you think that this one is steeper or less steep than the other values? Because here's the thing, just because it's going in a negative direction doesn't mean that it is not steeper, right? So let's take a look at this. I'm going to do a different color over here. Let's do purple. Starting with our lowest house, okay, we're going to create that right triangle. It's always a good idea to create that right triangle just so that you know you don't go too far. And then we're going to take it over to our point. Again, this is a common mistake. Don't do this. Okay, you cannot find slope going through people's yards. Okay, so we've got this one. We're going to go 1, 2, 3, 4, 5, 6. So in this case, we're adding 6 here, and then we have a 1, 2. Now this one's tricky. It is 2, but look at the direction that we're going in. This time, we went to the left 2. So anytime you go to the left on a number line, you're going to be subtracting. So it's actually going to be this -2 going to the left. Okay, so it doesn't change our number. It just changes the direction. So finding our slope, we have our change in y, which is plus 6, divided by our change in x. Now here's where your signs are important. We've got our -2 here. Because we went to the left, we have to put that sign with it. Because look at your slope overall. Look at your line. Now, just thinking about your 8th grade math, okay, your 8th grade teachers, they taught you that this was a negative slope. So if we look at our slope here, then we must make sure that we have at least a negative somewhere. Now, some of my students, what they'll do is they will go ahead, they'll do their bumps like this, and then they'll do their bumps like this, and they won't come over here and they won't write it, and they'll give me this, and then they'll say, well, Miss Hastings, I know it's a negative slope, so I'm just going to put that negative right here on the side, just so I know it's negative. That's totally okay, but you really have to be careful with your sign on this. So we went up 6 and we went to the left 2. Now we've got to make sure this goes in simplest form. So we're going to come over here and we're going to type this in 6. Now I don't put the plus sign because we assume it's positive, divided by, and then you have your negative 2. We're going to click enter and look, there it is. It's going to simplify that for you. So it's going to give me negative 3. Now, this is an interesting thing because it just gives you a whole number. Well, you're like, but Miss Hastings, I see the rise, I guess, but I don't see the run. Well, the same thing is going to be true here as if we just put it over 1. So negative 3 is also equal to negative 3 over 1. And I'll show you that on your calculator. Negative 3 divided by 1 is the same thing as negative 3. So in this case, this would be our rise and our run. Now we might keep that, we might take that negative 3 and bring it up and make sure it comes out to the side. Oh, I can't write today, sorry. And bring it out to here to the side. Totally up to you. So let's just recap for a second. When you're finding your slope or your rate of change, because they're going to use both words on your STAR test, you're going to be finding the change in y divided by the change in x. Again, the change in y divided by the change in x. You're going to start with that lowest point and you're going to calculate your rise and then you're going to calculate your run. You're going to want to make sure that as you do your rise, you put your plus sign, and then as you do your run, you decide if it's going to be going to the left or to the right. If it's going to the right in this direction right here, then it's going to be positive. If it's going to the left right here, it's going to be negative. So let's take a look at, say, this one over here. Now, if you notice, I've already got pretty points already there listed. So all you have to do is come over here and create your right triangle. So let's do that. I'm going to go all the way up to the top of my dot and then all the way over. And then we count 1, 2, 3, 4, 5, 6, 7. So plus 7. And then 1, 2, 3, 4. Now because I went to the right, it is plus 4. So to find our slope, we take our change in y, which is positive 7, divided by our change in x, which is positive 4. Let's see if it simplifies. So we come over here and we type that in. So we have 7 divided by 4. Okay, now if you notice how that does not simplify at all, so then we are good to go. It is 7 over 4. Now this is a positive slope because if you were thinking about it from a mountain, right, we read left to right. If I'm going up my mountain like this, then my altitude is getting higher. But if I'm going down my mountain like this, then my altitude is getting lower. So like on this one, this guy would have a negative slope. So whatever our answer is, it's going to have a negative. So we start with our lowest point. Actually, I'm going to make this a little thinner, sorry. And then we have our upper slope. We create that right triangle right here. And there we go. So we go up 1, 2, 3. So I went up 3 over 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this one's tricky. It is a 9, but look at what direction it's going in. It's going in the left, so we've got to keep that negative. So for our slope on this one, we have our positive 3 divided by our negative 9. Let's plug that into our calculator. Positive 3 divided by negative 9. Okay, make sure you keep it in fraction form. And look, there it is. It just tells you our slope or rate of change is negative 1/3. That is how steep our line is. Okay, that is how steep our line is. Okay, let's take a look at this one right here. Now this one's kind of tricky. Here's your x, here's your y, and here is your line. Okay, that's the line. Now, as we're going we're going to go from point to point. So I'm going to start with this point right here, and I'm going to rise how much? Going from here to here. Well, hopefully in your mind you were thinking that, well, Miss Hastings, you didn't rise any at all. So my rise on this guy is going to be 0. Now, if I'm going from this point to this point, well, that's just 1. So then my run of this guy is going to be 1. So rise over run, change in y over change in x. So let's put this in our calculator. So we've got 0 divided by 1. Boom shakalaka. It's just 0. So my slope is 0. So this is what it would look like if we had a 0 slope. Awesome. So again, a couple of these are just extra problems that you can go through. And again, all you would do is just come over here, create your right triangle, and then you're going to count 1, 2, 3, 4, 5. That's a plus 5 because I went up, and then 1, 2, 3. That's a plus 3 over here. Our change in y, 5 over our change in x, 3. You can put that in your calculator if you need to, but it's not going to be able to simplify because those are prime numbers. All right, let's take a look at this last one over here. Now, going from the lowest point to the highest point, we rise 1, 2, 3. So I rose 3, but I wasn't able to create a right triangle. So that's kind of interesting. So if I can't run any, right, because that's 0, here's my rise, here's my run. Let's see what that looks like in our calculator. 3 divided by 0. Notice how it says undefined. Here's why. Anytime you have some number divided by 0, it's not going to work. It's going to be undefined. So in this case, we would have an undefined slope. So our slope is going on to infinity forever and ever. So we actually can't define it. Okay. So again, these are all of the different types of slope. We'll come over here and we'll fill in some of these notes really quick. Hold on a second. So we come over here. The slope of a horizontal line is going to be 0. The slope of a vertical line is undefined. And again, some of you guys might have seen that later, or like in your past experience with math. Remember that up and to the right are positive movements, and down and left are negative movements. Okay. We have our different types of slopes that you can see over here. So we got our positive slope over here. It's going to look like this. You have your negative slopes. They're going to look like this. You have your 0 slopes like this. And then you're going to have your undefined slopes that look like this. Another way that can help you remember your different types of slope is Mr. Slope Guy. So we've got our positive slope and there's a plus sign next to it. We've got this other eyebrow over here. That's a negative slope. It's next to this one. We have our 0 slope and it's got your little zeros over to the side. And then we've got our undefined slope, which is our nose, just like that. So Mr. Slope Guy can help you remember different types of slope. Okay. And that is how you find slope from a graph, or rate of change from